So right about now, we are going to provide solution to Missy challenge on Cybertalent. So the first thing to do, while I share my screen, the first thing to do is to proceed to that website, Cybertalent. Check out the description of the challenge. Someone tried to brute force on IPs. So can you reveal what he hides? Then they gave us a link to download a pcap file. A pcap file is a packet file. Yes, and we know how to read packet file. That's with Wireshark. It's a popular tool, very popular. We already talked about it in previous class. So you click on this. When you click on it, it's going to download. You go to your download folder or wherever your stuff is downloading to. Mind you, what I said is click on it, it's going to download somewhere around there. You check it out. Now I've already downloaded it, so there's no need to download it again. So I would open my Wireshark, then share the screen for Wireshark. So I would open Wireshark. Now with Wireshark, I would now open the file. Now looking at the screen there, that's my Wireshark. So I would now open the file. You can see the various files that I've opened. So you can just go there. Then I've opened it before, so it's going to be easy. So now I'm opening it again. Now we can see all the files. There are actually plenty, right? Like how many? Let's even check the number. Sorry, I didn't get it right. Over 12,532 packets. Over 12,532 packets. Now, the code says, or the hint says, seems someone tried to brute force on IPs. So can you reveal what he hides? First thing we have to do is to analyze the packet. We have to analyze the packet. Now, using a packet analysis tool like what we are using here, which is Wireshark, we can actually filter and examine TCP protocol to identify any suspicious activity that might suggest a brute force attack on IPs. Before that is done, or before we proceed on that, I just need someone to briefly explain to me what he or she understands by a brute force attack. Anybody? Okay, Sanusi, you're the first to raise up your hand. What do you understand by a brute force attack, Sanusi?
What I understand by a brute force attack is that, like, someone trying to guess the password to a website or something which he doesn't have a knowledge about. So he'll try multiple passwords or some combinations to be able to get access to that website. So that's all I can say about what I understand.
Yes, thank you very much. That's just about right. What he said is actually correct. You don't know what the password is, but then you want to get the password. What do you now do? You are going to try different combination. Not like you want to force a door open. You try different combination of password to ensure that the door opens. Meanwhile, as you are trying, each information you send to the server is just like you are sending a packet. Each information you send to the server is like you are sending a packet. So just like Mr. Sanusi said, if you are sending multiple information, if you are pinging the server, you are sending multiple information to the server. You are just looking like you are sending packets repeatedly to the server. Now, we already described it in the previous class. When we're talking about networking, we talked about UDP, we talked about TCP, we talked about different kind of protocols that we have. Now, looking at this, the first protocol that it sent, we can see the source, we can see the destination. We can see the source, we can see the destination. We have UDP here. We have UDP. Now, going down, it's still UDP. It keeps on giving us UDP. So you can see RTCP there. So if we continue to move down, we can discover that we can see TCP, right? We are going to examine the TCP protocol. So forget about anything UDP that you are seeing. Forget about it. That's not what we're actually using. I already explained the difference between UDP and TCP. One thing about UDP is that UDP is connectionless. Yes, it's connectionless. There's lots of packets. So whenever you are sending something like information in text form, it's not done in UDP. It's done in TCP. Like the way we're having this video call, that you might hear what I am saying. That's if your network is bad. You might not hear what I am saying. That is, if there can be information loss. That's UDP. You get it doesn't actually perform the three-way handshake completely. It doesn't mind if 100% of the packet has been transmitted, right? So now, like I said, we are interested in just the TCP. So we come to this filter here and we search for TCP. As we filter only TCP, we press enter. So it's going to list out all the TCPs that we have. It's going to list out all the TCPs that we have. Now, we know for certain from the hints, since someone tried to brute force on IP, so can you reveal what he hides? Now, looking at this, can someone tell me, looking at this, you can see the source 192.168.1.7, destination is 3.67.245.95. We can see different sources, we can see different destination. Let me ask somebody that actually did the assignment to tell me what he thinks the source IP is. That the attacker's IP. From this, you should be able to tell what the attacker's IP is. Anybody? And you're going to tell me the reason why you think that is the attacker's IP. Aaron, you can unmute your mic and speak.
Okay. I think the attacker's IP is 192.168.1.7.
Yes, you are correct. Now, why do you think that's the attacker's IP?
Okay, since we are talking of a brute force attack from the description given to us, it simply means this person keeps sending more passwords to that account, meaning he's doing it automatically. So for each failed attempt, it will keep sending more password to that account also. So his IP keeps coming at frequent intervals, no much space in between them. I think that's what that's a little I know about it. Yes.
Yeah, thank you very much. That's correct. So what Mr. Aaron said, what Mr. Aaron said is actually correct. So we go back there and we've already established that his IP is what 192.168.1%. Remember at the very beginning, we saw up to 12,500 and something packets, right? So it's not going to be like too much work to be working with something like that, something of that nature. Now, mind you, please don't just think this is a game. It's not just a game. Real life challenges actually look like this. When you are presented with cases like this, like situations like this, okay, I don't want to go into details about one of the most recent work I did. I was just provided with like an MDOM file, and I was told to extract evidence of criminality there. That you have to like look at it. No, they're not going to tell you anything more. The marks they will tell you is the person is working in a company, the person is this and that and likes of that. So let's continue. So we have TCP. Now we want to filter it again. If you want to use and, you can use and. If you want to use this ampersand sign, you can use it, but you need to use it twice. So we know that the IP address is what 1.6.1.7, like you said. So we can say IP.src. We're using 192.168. let's quickly go through this. Okay, we can see a lot of packets here. Okay, good. Yes, before I input the filter for it, let's go through the packets and see. At least we need to be like very, very sure that the stuff came from the source. The source is 192.168.1.7. Okay, so checking everything now. Judging from what Mr. Aaron said, which is correct, you can notice that this guy is sent to this 192.1. We'll call it 0.1.7. It's sent to this. It's sent to this. It's sent to this and this. You can see that the servers are actually changing. They are trying to send like a scene that's trying to perform a three-way handshake. Now we proceed. He's still the one sending. You can still see him again. He's the one sending. We proceed. You can see, like a whole lot of this packet is showing him. He's showing this 192.168 as the source. So we can easily tell that that's the sender of that's the IP address of the attacker. Sorry, please, Christina, confirm if you can hear me well. Let me be very sure if it's from my end or yes.
I can hear you well.
Oh. So please, if you're having network issues, please just try to fix it up from your end. Okay, so now, like we did the first time, TCP, we already did this. We have already established that the source is from this. Right? So we move to the next one. We want to filter just this source, IP.src. We know. What is the IP address again? 192.168.1.7. You press enter. Now let's look at what we have here. We filtered it just TCP, then the source is from this. So we know that we are dealing with TCP1 and we are dealing with just those ones that have the source from this particular IP. Now looking at everything, you will discover that this particular one here, look at this particular one. Let's quickly analyze this one briefly. So we have is a scene that's from the three-way handshake. It's a TCP segment of a reassembled PDU. It's a TCP segment of the reassembled PDU. Now let's check out the information there. Look at the first one that we have, just application data, this and this. And let's try to follow this one. Let's follow it, see if we have anything reasonable. Okay. TCP string. Now, judging based on what you can see on the screen, we can see 70 here. Let's proceed further. Oops, the stuff has changed. IPFS. I didn't do anything strange. I just repeated the stuff I wrote before. Is now let me copy the stuff so that in case it goes away, I will be able to do it. Now let's look at what we have. We still have a whole lot of information. We have a whole lot of information. Now, what is interesting about this? The packets are still plenty, right? Packets are still plenty. We keep checking, keep checking. One thing you should observe about these packets that are indicated in black, it means they're actually bad packets. Now, since they are bad packets, I'm trying to do it in such a way that you would understand properly. Now, we have a whole lot of packets still, even after filtering. After filtering just the TCP packet and filtering those ones that the source address is 192.168.1.7. But then we have a whole lot of bad packets. So we are going to disregard the bad packets. Now let's go to just this where we have these good packets. Let me make this thing bigger. So going to where we have this, where we have a good packet. Let me scroll up. Now look at this green section. Green. You will notice something. It says this is coming from before now. It was retransmission. There was like retransmission. Most likely the scene this thing did not work. It didn't work. Now after then we had, notice this guy was transmitting to 118, 50, 67, 114. Now upon coming here, started transmitting to 124, 70, 76. Anyways, all these ones should not really concern you or should not really bother you. It's telling us that this is TCP segment of a reassembled PDU. TCP segment of a reassembled PDU. We check the next one. Still the same thing. Now, there's very high chance that whatever information that we are looking for is contained here. It's contained here. Then we move. Whatever it is that we are looking for is contained here. This guy is a bad packet. This black one is a bad packet. So we are going to disregard it. Now, what do? It's simple. We are going to follow this TCP stream. I don't know if you can see the new window on my screen. Yeah, I thought as much. Thank you. Let me share my entire window. Oh my goodness. Yes, please, can you see Christian, please let me confirm if you can see 7C on my screen.
Yes, I can.
Okay, just 7C, right? Okay, thank you. Good. Now, so we are going to note down. We are going to note down. Oh, the command keeps going away. TCP IP.src equals to 192.168.1.7. We go back to where we have good packets. So we come back to here. Please let me copy this in again. So in case it goes away. So now we are going to check this out. I'll follow, then I'm going to follow the TCP stream. I want to see what's there. The information that is given there is 7C. So we are going to write it down. So I'm just like going to write it down somewhere. 7C. Going over to the next. We check the next one. Now, a very good way to see what is there, instead of you to keep following, as you right click, then you follow, instead of you to go through that, like this second one now, look at what I will do. I'll right click, I'll follow, then I'll go to TCP stream. Then I can see 46 there, right? Good. So instead of me to keep doing all those ones, a faster way of doing it is this. Now this is where the good packets are assembled, right? So you can see TCP segment of a reassembled PDU. Now I will just come here, look at this section here, 46. That's where the payload information is. So I'm going to just write it down from here. I've written the first one. You can see it has changed, 72. The next one, 46. The next one, 4C. The next one, I'm writing all these things down, 41. The next one, 47. 7B, 4G. I'll keep doing it. I'll keep writing everything. I'll keep writing everything. If I get to this one, that is a bad packet, I'm going to write it down. So before that one, I had 87. I've written down. This bad packet, I'm not writing it. Next is what? 20. Okay, Christian, please confirm if you can hear me. I stopped at
I can hear you. 4D.
4G, right? The network was bad.
Yes, I noticed.
Can you also see my screen? Can you see my screen, please?
Yeah, yes, I can. I can see your screen.
Okay, so somebody that's giving me see those numbers. This is I'm seeing the number 370, 7G. That's actually the last packet. So if we now continue from here, all these ones are bad packets. We are not looking at it. This is the last packet I dealt with. This is the last good packet. TCP segment of a reassembled PDU. So you can see it's 7D. The one above it is what? 24. So now after writing everything, I can now, I'm going to take that stuff, is in hexadecimal. Sorry, base 64, I mean to say, base 64. I'll take it, then I'll now go to CyberChef and convert it. Let's go to CyberChef. We go to CyberChef, then we are going to convert it there. Okay, now from base 64, look at it. I'm going to select this from base 64. I come here, Control V. Oh, there should be a mistake somewhere. Sorry. Four, six, four, one. Let me check the numbers. Let's see from X. From X. Now, from X, that's hexadecimal, is actually flag, missed, whatever it is. Now you will notice something. I started from 46, right? Yeah, because if you start from this first one, let's check out the first one. The first one is actually the first one there. The first packet is actually 7C. Let's put 7C and see what information. I mean, the first packet, when I started checking those reassembled whatever 7C, it has already dish. Okay, still similar. So by the time you highlight everything, in the assembled package, you get this. Once you get this, you can copy it from here. What I'm displaying on your screen currently is actually CyberChef. So you can copy from here, then you go and paste it in your Cybertalent, then you are good. So that's all for that assignment. If you have any questions, you can always ask. You can always ask in the ask your question.